The concept of finding the area under a curve is fundamental aspect of integral calculus, which has broad application across various fields such as physics, engineering, economics, and biology. This process involves determining the total area that lies between the curve of a function y equal fx, the x-axis, and the vertical line at s equal a and s equal b.
Of shaded region. First, we look at the graph. Then we take out the information that given from the graph, which is y equal to x square minus 4. Then we write down the equation ax equal to integrate b y r integrate to 0 x square minus 4 times dx. Okay, then we solve the first equation by we multiply the x outside the columns to inside. So the x square is going to be x3 and minus 4 will be minus 4x. Solve this equation and it's gonna be 4x4 per 4 minus 4x square per 2. How we get it? By we add 1 to the power of the x, which is x3, we add 1 and gonna be x4 per. And how we get the 4 bottom is we drag the new power to the bottom 1. Same with the next, which is square 2. After that, we separate it to the two section by we exchange the x into 2 and other we change it to 0, like x like 2 4 per 4 minus 2 equal, then minus 0 4 per 4 minus 2 0 square. After that, we use the calculator to calculate the equation. The first equation gonna be 4 and the next is 8. So 4 minus 8 gonna mean negative 4, and we put the unit, and we cannot leave it like that. We're gonna use this to make it to be 4 unit negative. That's all.
Question given R is the region bounded by the x-axis and the curve y equal x square plus 4x minus 3. We use the R under curve formula, which are a equal yx dx limited by 1 to b. We insert the value into the formula. It will be negative x square plus 4x minus 3 dx limited by 1 to 3. Then we integrate the equation. The equation will be negative x cubed per 3 plus 4x square per 2 minus 3x per 1 limited by 1 to 3. We insert the limited into equation. First bracket with limit of 3 minus second bracket limit of 1. The final answer will be 4 per 3 unit.
In conclusion, understanding the area under a curve is crucial for solving numerous zero problems. By using integration, we can precisely calculate areas, which helps in analyzing physical phenomena, optimizing economic models, and understanding biological processes. This mathematical tool not only aids in theoretical studies but also in practical application across a wide array of disciplines.
Okay, first of all, before we start our calculation, I want to introduce about volume of revolution. The volume of a solid of revolution is a classic topic in calculus, particularly in integral calculus. This concept involves rotating a two-dimensional region around an axis to create a three-dimensional solid. The goal is to find the volume of this resulting solid.
Okay, here we got an example of the question of volume of revolution. So the question is the region bound by the graph of y equals to x square, x equals to 3 and x equal to 6. It's revolved in x axis. Find the volume of resulting solid. So the first step is we need to sketch the graph, which is what we have here. And the formula for x-axis graph is v equals to pi fx square dx. Fx means equals to curve y. Okay, for the next step, we have to find the volume of the disc, which is in the graph at the x3 and x6. Firstly, we need to replace the fx, or known as curve y, with the y equals to x square. And as the result, we get pi x square n square dx. And we need to multiply the square 2 with x square. And hence, as a result, we get pi x4 dx. For the step 3, we need to evaluate the integral and compute the volume of the solid. So we got the integral is 6 and 3 pi x4. So first we have to integrate x4 first, and as a result we get pi x5 per 5 dx. Next step, we need to move 6 and 3 to integrate it by replace x with 6 and 3. Now that we finish integrate and replacing x with 6 and 3, we got pi and 6 square 5 per 5 minus 3 per 5. So we multiply the 6 with square 5 and got 7,776 per 5 minus 3 per 5. So for the final step, we complete the minus, and as a result we got 7,773 pi per 5 unit square 3.
Okay, the question is the region bounded by the graphs of y equal to x square, y equal to -2 and x equal to 0 is rotate about the y-axis. Find the volume of the solid that results. Then the next step is find the volume of a representative disc. This is the formula that we use. Then we replace the formula to v equal to integrate 0 -2 pi x square dy. Then v equal to integrate 0 -2 pi y dy. Okay, the step 3 is evaluate the integral and compute the volume of the solid. V equal to pi y square over 2, 0, negative 2. Then we replace the y to the numbers. So the calculate is pi 0 square per 2 minus negative 2 per 0 square. Then pi 0 minus 2. Then we calculate the 0 minus 2, so we got the negative 2 pi unit 3. So the answer is 2 pi unit 3.
In conclusion, the volume of revolution is a powerful tool in calculus that allows us to determine the volume of three-dimensional objects formed by rotating two-dimensional area regions. By using either disk or shell method, we can handle a wide range of problems and applications in various fields.